Hi everyone and welcome. Today's webinar will help you unlock the power of geocells as a value engineering solution for your mine infrastructure. We'll discuss how the GeoWeb 3D soil stabilization system offers a better approach to soil stabilization challenges when accessing sites over soft ground, controlling and containing stormwater, protecting geomembranes in basins, tailings and heap leach pads, and reclaiming slopes at mine closure. Through 3D confinement and the strengthening of infill, less material is required and on-site waste rock can be used. The GeoWeb system offers increased speed of operation, lower maintenance, safer installation, and lower total cost of ownership, helping you meet environmental, social, and governance goals while improving production. I'm JP, the business manager for Presto Geosystems, and I meet with specifier and contractor clients to secure and support our international network, driving new opportunities with focuses on roadways, mining, environmental remediation, hydrocarbons, and wind energy. We manufacture industry-leading erosion control, stormwater management, and porous pavement products, all made in the upper Midwest of the United States. Through an extensive national and international distribution network, we offer technical and site support, as well as free project evaluation from our in-house design engineering team. Here are the things I hope you get out of today's presentation. Understand the benefits of geocellular confinement for high-performing, long-lasting mine infrastructure, to explore mine applications for geocells in haul road, slope, channel, and containment pond solutions, and to learn how 3D geocellular confinement can produce higher performance and lower maintenance mine site solutions. We'll share a few case studies, and there'll be time for questions at the end, so please enter them in the questions window. You can also provide feedback or additional questions through a follow-up email or by contacting us directly at prestogeo.com. For now, all are muted, so please follow along or enter in the questions tab as appropriate. Thank you. What is value engineering? First thing most people think of when hearing value engineering is cutting costs. And although cost is a major project factor, value engineering has to be about maximizing value, not simply reducing cost. A reduction in cost could result in disproportionate reductions in functionality, and then a cost reduction could result in reduced value. Value engineering identifies opportunities to reduce costs while improving functionality. The aim is to deliver the project's functional performance requirements at the lowest cost, preferably the lowest whole life cost. For construction projects, this means an investigation of materials availability and cost, construction methods, transportation, project-specific restrictions, plus stakeholder issues and benefits, environmental and sustainability impacts. Adoption of a new and innovative material or method, such as substitution of materials and methods with lower cost alternatives, can significantly reduce costs, but they must do so without reducing functionality. That's where we step in to help you, analyzing that total package for a value engineering mine solution. One of the reasons Presto Geosystems offers the world's most complete multi-component cellular confinement system is that we back our innovations with accredited research and testing, and have done so since the creation of geocell technology in the late 1970s. From industry-leading geocell researchers in the US and around the world, to active participation in geosynthetics committees to uphold the integrity of the industry, including with ASTM D35, ARIMA, AASHTO, TRB, ISO, and IGS. The 3D GeoWeb cellular confinement system is perfect for mine industry solutions as it stabilizes unstable soils vertically and horizontally in the applications of load support, slope protection, channel armoring, and earth retention. Today's presentation will focus on permanent and economical solutions with the GeoWeb system for a number of challenges facing the mining industry: stabilization of soft soils for access to site and haul roads, control and contain rainwater, protection of geomembranes in basins, tailings, and leach pads, and reclamation of slopes at mine closure. Through 3D confinement and by strengthening the fill, less material is required and waste rock can be used on site. The GeoWeb system offers improvements in operation, maintenance, installation, and safety at a lower total cost, giving your mine site some powerful value engineering solutions in reducing costs while improving functionality. The GeoWeb system is our version of GeoCell technology and consists of two main attributes. The first is the cell size. Cells come in 3 diameters, small, medium, and large, and varying cell depths. Cell sizes are selected following an evaluation of project-specific needs and site conditions. The ultrasonically welded seam, where all the connecting points are, is very important to the function of a geocell. The stronger the seam strength, the better the performance the geocell will be. Strong seams allow for heavier infill material, steeper and taller slopes, and better lifetime performance. GeoWeb is produced for consistently strong welds at cell junctions, high stress crack resistance, and overall toughness and long-term durability in the environment. We do not use fillers or exotic polymer alloy blends, which can ultimately reduce that weld strength and environmental stress crack resistance, and that are offered in some competing products in the name of increasing cell wall stiffness. To avoid weld failures and the damaging effects of differential settlement, uniformity in performance across all the elements of a geocell system is much more important than stiffness alone. Here we see a typical GeoWeb panel as it comes tri-folded on a pallet. GeoWeb is lightweight and requires no specialized equipment for installation. Sections flex like an accordion so they can follow the natural contours of your worksite without being confined to a rigid set of dimensions. It can ship and store easily with 12,000 to 20,000 meters squared per container, or 100,000 to 200,000 square feet per truckload. The infill, or what you put into that container, is the second important attribute of the GeoWeb system. An important benefit of the system is that low-quality aggregates, sand, or on-site reclaimed material can be used to fill the geocells. Using reclaimed sand or aggregates can save a significant amount of money on materials and transportation costs. We can also remove fines if drainage is desired, as the geocells provide the confinement and aid compaction of cohesionless soils. Without fines, we can significantly improve drainage and let water flow freely through the system, preventing poor pressure buildup and overall cross-section failure. The ability to use those low-quality sands and aggregates with friction angles in the 20-degree range really sets the GeoWeb system apart from geogrids and geotextiles. Those products require high-quality materials with high friction angles to achieve their optimal performance. With the GeoWeb system, materials with low friction angles are fine, as the GeoWeb panels reach their full potential even with these poor materials, which can provide significant cost savings to you. The GeoWeb system can often reduce the cross-section required by half. In order for a geocell system to perform uniformly, it's critical that both the factory welded junctions and the field joined junctions that connect individual panels perform at a level commensurate with that of the cell walls. The 3 primary elements of the system, the cell walls, The internal junctions and the connectors have to perform uniformly as a complete system. So any incremental improvement in one characteristic, such as cell wall stiffness or ESCR, is only valuable if a complementary improvement has been made across the other components of the system. GeoWeb is manufactured using a proprietary blend of high-quality virgin HDPE. Our proprietary formulation has stood the test of time for more than 40 years. And for most typical sites, GeoWeb will retain its durability for greater than 100 years, with lab testing indicating 149 years without degradation, even at full exposure to the elements. We stand behind our numbers so you can deliver certainty in the solution and build with quality materials you can trust. Additionally, GeoWeb and all our accessories are 100% made in the USA under strict quality assurance and environmental control processes. Presto's GeoWeb system is equipped with numerous design and construction components that increase strength and speed of installation, each of them with specific strength values, so calculations and modeling replicate real-world forces, and the solution is designed for the project needs instead of as a commodity one-size-fits-all product. The system components are all the supporting pieces that help the GeoWeb protect the surface and base layers and also ensure relatively uniform performance of the interconnected system, thereby protecting against the damaging effects of non-uniform deformation and differential settlement in response to applied loads. The components make it safer, faster, and easier for installation. The ATRA-key is the first component for a completely integrated system, connecting each individual panel of GeoWeb into a single web that covers your slope. It allows for faster installation of GeoWeb and will last the lifetime of the project, ensuring that the GeoWeb system will not fail under anticipated loads. The specific engineering values of the ATRA-key will ensure the system holds up to loading over time without the corrosion seen in staples or the failure of underperforming cable tie systems. Our spec sheet calls out the specific engineering values for this patented connector, and the ATRA-key requires no special tools, generators, or compressors like staplers would, nor any three-handed acrobatics like cable ties or two-piece connectors. All the power of the ATRA-key with a simple insert and turn positive connection. As slope angles increase, the driving force of the infill material exceeds the available frictional resisting force, and additional anchorage is required. The ATRA anchors hold the GeoWeb to slope and penetrate into the ground. If corrosion resistance is required due to project conditions, Presto has an HDPE ATRA speed stake designed to work with the GeoWeb and offer higher resistance to extraction than rebar or J-hooks. For steep slopes, a slope where the native soil is highly erodible, or over a surface that cannot be punctured, such as a liner, tendons can be used. The ATRA tendon clips transfer the load from heavy infill material to the tendons and crest anchorage system. Only the ATRA tendon clip is specifically designed to fully transfer safely and securely the forces placed upon the geocell. Every accessory and every feature has been designed and tested to specifically work together, so we go from problem to design to construction solution with a system where the modeling replicates real-world forces. Now let's talk about how to take advantage of the benefits of geocell confinement. The first application we'll highlight is in load support. The GeoWeb system stabilizes unstable soils, vertically and horizontally, and in load support applications offers various benefits for mine clients. GeoWeb geocells were invented for supporting heavy loads over soft soils, the perfect solution for haul roads in mine installations. Before giving some specific examples with case studies, I'll explain how and why GeoWeb geocells work so well for load support. GeoWeb was invented for solving a military problem: how to cross beaches with heavy military equipment. The Army sought a quick-to-deploy road solution, and a Presto engineer, Gary Bach, collaborated with Steve Webster of the Waterways Experiment Station to weld strips of polyethylene and form the first geocells. The system evolved to include UV stabilization and other improvements such as perforation, texturization, and connections, but the concept of geocellular confinement and the particular strength properties of HDPE have been proven by more than 4 decades of GeoWeb load support. Likewise with the use of low quality and low friction angle infill. Here we can see the stresses on the subgrade with an unsupported subgrade on the left and GeoWeb reinforcement on the right. Notice how there's a complete elimination of the highest stresses at the surface with GeoWeb reinforcement. Stresses are reduced and distributed over a wider area, which we call the mattress effect. This mattress effect reduces the stress reaching the subgrade and leads to a significant decrease in deflection and rutting. The GeoWeb 3D system works this way. When a vertical load is applied, the active earth pressure in the loaded cell pushes back against the passive earth pressure in the adjacent cell to form a stable system. Being confined, the soil responds passively. The infill is limited in its movements, represented by the yellow arrows. The cells adjacent to the loaded cell provide passive resistance, shown in the diagram by the red arrows. The load is dispersed over a greater area in the lower layers, as each cell helps support the ones around it. The GeoWeb cell walls also transfer hoop stress, as you see with the blue arrows, which is important in keeping the system intact and creating a mattress effect. The strength of the seams around each cell, the material properties of the individual strips, and the connection method between panels are all important factors in determining how the geocell system can improve load-bearing capacity. Strong seams, semiductal resin properties, and integrated connections are all critical to a well-performing system. By eliminating that lateral particle movement, the GeoWeb can stabilize the surface, eliminating the need for constant maintenance. Here we see the impressive load support benefits of a standard AASHTO H25 loading parameter, 80,000 pound loaded dump truck, on a partially filled GeoWeb panel over a soft subgrade. We see how the cells push back against each other to help support that load, and only the adjacent cell needs to be filled for that support. A great benefit to using the GeoWeb system is you do not need to have every cell completely filled before your road is usable. You can reduce construction time and materials with this approach. The GeoWeb system provides less rolling resistance, less required maintenance, less expenses needed for fuel, and less structure required to support those loads, all with better production, better cycle times, better operational costs, and better installation. A great value engineering solution for your site access and haul roads. The 3D structure functions well in remote areas where clean aggregate is scarce. Compact GeoWeb sections ship efficiently to job sites and require less trucks to transport the materials. On-site sand infill, in this example, is used so that costly aggregates won't be necessary. Nearly any locally available granular infill, sand, or even waste rock could serve for the GeoWeb geocells in your projects. In the majority of cases, the GeoWeb system can also reduce the cross-section depth by up to 50%. GeoWeb allows stabilization with a reduced cross-section, ideal for your underground haul roads. Let's look at a haul road example for a specific case study. This case study is for a mine in South America and a great example of the power of geocells for a value engineering solution. GeoWeb geocells were incorporated into the design of the haul road at an active mine in Suriname, with heavy loading over soft subgrades and a local scarcity of quality angular aggregates. The prepared subgrade strength exhibited a California bearing ratio, or CBR, value of 2.5%, consisting of saprolite and clay. Anticipated loading included the CAT 785 haul trucks, which are 275-ton vehicles, and the haul road useful design life of 10 years at 250 movements per day. Geocells offered a value engineered design option with multiple benefits. The sticky clay soils made the road impassable with every hard rain, and adequate aggregate materials for a standard construction solution were not to be found. GeoWeb geocells offered that value engineering solution with just one layer of 6-inch or 15-centimeter geocells, being able to support the heavy haul truck loading over soft subgrades and reduce the total thickness to 30 inches, reduced from the 60 inches suggested by standard design guidelines. Geocells dramatically increase the shear resistance of the infill, which allows the use of lower quality fill to carry concentrated loads that would otherwise require crushed aggregate to prevent localized near surface shear failure. Here's that one 6-inch layer of geocells being installed. For an efficient and cost-effective solution, the infill was locally available coarse river sand, known as small miner's residue, and the GeoWeb haul roads function well. Even with the hard tropical rains. The results of the GeoWeb installation offered notable benefits. A great reduction in the total cross-section needed, reducing it by 35% with a coarse sand wear surface, and by 50% with an aggregate wear surface. The estimated savings per kilometer are around $150,000 US, about $100,000 per mile in savings. Since installation, there has been a reduction in road maintenance costs of over 65%. There are no downtimes due to rains, and there have not been any deep ruts observed since install, multiple years now. There's less vehicle maintenance and less fuel required, better productivity and operational costs, safer site conditions, and this expansion opened before the scheduled date and under budget. All in all, a very satisfied client. Project calculations included an analysis of bearing capacity improvement to evaluate the combined benefits of lateral confinement from geocells in conjunction with the tension membrane effect of the underlying high-stress woven geotextile to confirm the proposed approach would meet design requirements. The analysis indicated the stabilized section would offer a substantial increase in the allowable bearing capacity over existing subgrade conditions, without which it would have an allowable bearing capacity of around 20 to 30 psi at best. An analysis of hoop stresses under working loads was also performed to verify the geocell system components would be able to withstand the demanding load requirements. Hoop stresses were compared to the ultimate tensile strength of the perforated cell wall, as well as the strengths of the internal and mechanical junctions. In the case of the junctions, ultimate strengths for all three primary modes of potential junction failure, shear, peel and separation or splitting, were compared to the fully developed hoop stress under working loads to calculate factors of safety for each mode. For cell wall, the factor of safety against cell wall rupture was calculated. As shown, all of the system components were verified to meet the design requirements. I invite you to use our free preliminary design service to see how we can help save money and time for your mine site. With a little bit of design information, we can run calculations and determine the ideal solution to resolve your site's soil stability problems as a value engineering option or as part of your initial design recommendations. Our next application for GeoWeb will be for slope protection. The GeoWeb system stabilizes unstable soils, and in slope protection applications, that means we can control erosion while at the same time sustaining vegetation with steep slope angles. The GeoWeb system allows flexibility in a mine slope reclamation solution and allows vegetation of tall, steep slopes such that would otherwise not be able to sustain vegetation. GeoWeb also allows you to suspend a protective layer to vegetate or to hard armor over geomembranes without the need to perforate the liner for anchors. And as you see here, able to sustain vegetation and control erosion in that protective layer. Here's another example of the GeoWeb system with tendons over geomembrane. The anchorage system with atrotendon clips allows for a safe and strong installation without the need for anchor stakes or perforation. The atrotendon clips transfer loads from the geocell wall to the tendon and the tendon to the crest anchorage, whether that be dead man pipe as you see here or a type of earth anchor. Here's a case study from a mine slope at the foothills of the Canadian Rockies. The soft shale slopes were degrading with noticeable scour and erosion in an area above an MSE wall supporting a new coal conveyor. A long-term stabilization solution was critical for this project. We worked closely with the engineer of record, assessing system options to include anchorage for the loadings, for snow loadings. A tendon GeoWeb system was designed with the atrotendon clip load transfer devices and a deadman crest anchor for this 1.4 horizontal to 1 vertical cut slope. Here we see the tendon tie-off in the anchor trench, as well as the non-woven geotextile for separation. Here the anchor trench is filled with on-site material, and you can see part of the conveyor system at the toe of the slope in the photo on the left. Much of the GeoWeb slope protection system can be pre-assembled on the crest of the slope and then expanded downslope for infilling. Once the GeoWeb slope system is connected and placed, it is infilled from crest to toe. The GeoWeb sections were filled with topsoil, and the area was seeded for vegetation growth. Here's another case study for mine slope reclamation, this one in Peru. As you can see, the slopes are very steep, with cut slopes having angles greater than 70 degrees in some cases, and much erosion. A complete and complex solution was required, including the design and construction of integral rainwater channels with energy dissipators, all with the goal of managing stormwater and preventing slope erosion with little to no maintenance long term. Long-term protection and a complete solution to control erosion, reclaim mine slopes, and control stormwater, all thanks to the GeoWeb system. We saw an introduction to GeoWeb channel protection in the previous section, and now we'll detail the GeoWeb mine channel protection system. So I've got a simplified diagram here to show how the different system components interact with the GeoWeb to form a complete system. We'll talk about each of these as a component. I want to stress that when I say channel, I'm talking about protecting an area that can be the full width of the channel plus the side slopes. It could be just the bottom plane of the channel, or even just the side slopes like an embankment or dam structure. Full flexibility here for where you want to protect and for your project needs. The process for building up a channel protection goes something like this. To begin, we have our channel with standard dimensions and side slopes. Depending on the infill, a geotextile separation layer may be required. Then the GeoWeb panels are put in place. Note how the panels typically have a crest anchorage at the top of the side slopes, as well as a horizontal turn at the top. This is important for the anchorage and to prevent water from flowing under the panels and scouring it. We have two options for anchoring. The first, using Atra anchors or Atra speed stakes, and those are placed along the face of the channel and at the crest. The second is to use tendons and a crest anchor system. So all the anchorage is at the crest of the side slopes or embankment, not along the channel face. The cells are then filled with the desired infill material and the system designed to create a stable channel surface even when the maximum velocities and shear stresses occur. Once again, we offer a free project evaluation service and are happy to walk through the options to see what is best for your site needs. The use of the 3D GeoWeb channel protection system is much more effective than two-dimensional solutions that are subject to scour or lifting. The fill material that's confined in each flexible cell is protected against erosive forces, making the entire channel or embankment more stable. Two-dimensional solutions such as erosion control blankets or cementitious blankets do not protect the channel from the hydraulic forces of the water, so the channel can fail even with that 2D protection system in place. Those systems also may be prone to uplift. The GeoWeb channel system provides protection with a variety of anchorage and infill options that best suit your project needs. Here we see channels with vegetated infill, aggregates, and concrete. GeoCells improve the hydraulic performance of conventional channel protection materials. Presto has done extensive testing with the hydraulics lab at the University of Colorado State. And their lab has a static drop of over 80 meters, about 260 feet, for nearly limitless flows through their lab flumes. The CSU tests gave us formulas to calculate solutions for flows in vegetated geoweb channels up to 9 meters per second, or about 30 feet per second, in aggregate channels, reducing rock size by 2 to 10 times compared to riprap and the Abbottson-Johnson or U.S. Army Corps of Engineers formulas, and in concrete channels with flows of more than 11 meters per second, or over 36 feet per second, with the GeoWeb system surpassing the flow limits of the lab flumes. Vegetated channels are not typical solutions for mine installations, and aggregate channels are often used for mild slope installations, like this example of an outfall channel for Rio Tinto. Or this example with shallow embankments in Arizona. The GeoWeb channel infill can be waste rock, readily available on site, and less costly than importing any fill. For extreme flows and a permanent worry-free solution, concrete infill is recommended, as used in this spillway project in Peru. That concrete recommendation is especially important at mine closure or when limited site observation and access is available. Here are some more examples for remote site installs from San Andreas and Tyrone. And there are many, many concrete GeoWeb channels at the Yanacocha mine sites. Traditional methods often open the possibility to failure points, in addition to having longer construction times. If there's differential settlement or seismic activity along the channel, an inflexible solution should not be chosen. We're going to look at a case study for a high flow mine channel in Guatemala. GeoWeb allowed for a resilient and fully armored seamless channel without the need for expansion joints and the potential failure zones seen with traditional port channels, all with a reduced cross-section in an active seismic zone. GeoWeb geocells can be incorporated to handle high-flow stormwater in remote locations, and their long-term resiliency makes them ideal for mine closure applications where environmental restrictions hold sites to consistent and permanent high performance. Yet site access often only allows for occasional monitoring post-closure. Expanded durability standards are especially important with increased frequency of record storm events, and if either seismic activity or differential settlement is expected. As our case study will discuss, this mine site in Guatemala experienced record storms and strong seismic activity, and the geosynthetically enhanced channel armoring delivered consistent performance that stood up to the challenges. The channel had anticipated hydraulic flow of 425 cubic feet per second, about 12 cubic meters per second, and about a 5.14 meter per second velocity over a length of 400 meters. There were rapids included in the channel, and the client wanted to allow for excavator entry as needed for future cleanout. The mine site was originally considering an 8-inch or 20-centimeter reinforced poured concrete channel and looked to optimize design while maintaining a trapezoidal channel formation. While design calculations supported a 4-inch geocell system to still allow that excavator support and match the resiliency needed for this channel, the mine site preferred to split the difference with a 6-inch depth for additional factor of safety. This was still 2 inches thinner than originally budgeted, so it already offered considerable savings in concrete costs. The design included a non-woven geotextile as a separation layer, 6-inch geocells with polypropylene tendons, and a load transfer system with 4,000 psi concrete. The GeoWeb channel protection design incorporated our strong polypropylene tendons, the ATRA key connectors, and the ATRA tendon clip load transfer devices. Here you see the connection with the deadman anchor with the tendons. First, the channel bottom was filled, and then the side slopes working from top to bottom. Note the yellow tendons and the deadman anchor at the crest. These components are determined project by project based on the details of the specific channel. Also note the difference in concrete color, with a previous pour showing as the light white infill color and the current pour showing as the darker gray. Rapids were incorporated into this part of the channel design, with the GeoWeb geocells transitioning seamlessly into the structure. And here joining the rapids with the rest of the GeoWeb channel. Again, incorporating multiple pours without any issues of that transition. Here's a drone view of the GeoWeb channel installation with the rapids here. The GeoWeb channel protection system allowed for a resilient and fully armored seamless channel without the need for expansion joints and the potential failure zones seen with traditional poured concrete channels. After multiple years of performance without incident, even with record storm events and strong seismic activity in the area, with soil saturation, overflowing rivers, and landslides, the GeoWeb channel continues to perform as expected. Geocells with concrete infill have the long-term resilience and economy to be considered a best practice and are considered among the solutions with highest long-term performance results from the U.S. Bureau of Reclamation's 10-year canal lining study. Here we see a comparison of allowable velocities and shear stresses for various channel lining alternatives from the United States Department of Agriculture. The GeoWeb system provides protection and flexibility, as shown in this mine closure channel in Mexico, using big riprap fixed in place with grout for a rockfall area. Or with these rapids in a Peruvian mine installation. Again, incorporating those energy dissipators as an integral part of the GeoWeb concrete pour. The flexibility of channels with various options for anchorage and installation, and various options for infill. All in all, a system of complete channel protection for your project needs. Our in-house engineering team will gladly provide an evaluation for your mine channel and help provide a GeoWeb channel solution that satisfies all your project needs. Visit our website, prestogeo.com, for a free project evaluation. Our final application today will be for earth retention systems. The GeoWeb Earth Retention System can offer global stability and support of surcharges, even with seismic activity and differential settlement. Retaining walls serve to contain soils and protect utilities or storage tanks, and can offer global stability for very steep slopes, like this example in Central America. GeoWeb walls also function as containment dikes, with or without vegetation, and unlike block walls, GeoWeb walls can withstand reasonable differential settlement, hydrostatic pressure, and seismic conditions. Our team of engineers can help with the retaining wall design, and we also offer free design software licensing. Visit prestogeo.com, Earth Retention, for more information and to request a copy of your own for the MSC design software. The GeoWeb MSC wall software was written by Professor Dov Lashinsky and can be thought of as an extension of the RISA software. It's highly versatile and can model a range of site conditions. It can be used with walls and slopes and can perform both internal and external stability calculations, provided the soil properties are known. The GeoWeb system stabilizes unstable soils vertically and horizontally in the applications of load support, slope protection, channel armoring, and earth retention. GeoWeb offers improvements in operation, maintenance, installation, and safety at a lower total cost, giving your mine site some powerful value engineering solutions. Every project is different, but the Presto Geosystems team has a solution that's right for you. The GeoWeb system can be added to projects to provide a more stable, longer lasting, and flexible system. It's a complete system solution for ease of installation and peace of mind. I've mentioned this a few times, but it's very important that each one of your projects requests a project evaluation to ensure that the recommendation is based on your site-specific conditions. We don't believe in standard charts or graphs, since no two projects are the same. Even one phase to the next can be different. We're glad to analyze your site-specific data and offer a recommendation that will meet your project needs. Again, this is a complimentary service, a free project evaluation. We deliver quality and over 40 years of expertise. guaranteeing that each shipment meets or exceeds our specs so you can deliver certainty and build with quality materials you can trust. No disclaimers or concerning fine print. One of the biggest questions we get is about cost. No surprise there, especially if this is a new technology for you or your area. Having an idea of how much the GeoWeb system costs compared with other stabilization techniques can be important. Our case study shared today hinted at some cost savings, and here's another look with basic comparisons for the GeoWeb system in a load support application, in this case a gravel access road. This comparison shows the difference in both price and cross-section depth for an aggregate-only unreinforced section, a section using geogrids and geotextiles, and then two sections showing the use of the GeoWeb system, one with aggregate and one with a salvaged on-site material as the infill. We see that the GeoWeb system is both thinner and less expensive than the other cross sections, significantly so when on-site material can be utilized. In fact, you can see a 40% savings to be realized compared to the geogrid and geotextile section, which does not allow for the use of most salvaged or on-site material, as high friction angle, well-graded material is required with the use of grids and textiles. Of course, your aggregate costs, distance to quarries, etc. might vary, but this will give you a general idea of the savings that can be achieved. In addition, we can help you calculate carbon costing, which this doesn't even touch. We have a detailed website at prestogeo.com with many tools available for your projects. We have quick links for information from design through construction and a learning section where you can watch previous webinars. We also have a link to our YouTube channel where you can see hundreds of videos. Part of our complete solution is our technical assistance. We provide free project design evaluations, and the form is on our website. Just click on this tab to get the process started. The engineering team here at Presto Geosystems works closely with project engineers and consultants, offering a free project evaluation service. Fill out the form with as much information as you have, including attaching documents such as geotech reports, project site photos, or other information, and it comes directly to us. Then within a few business days, our in-house design engineering team will provide a complete design evaluation, including a written summary, manufacturer's calculations, cross-sections, specifications, infill recommendations, and anchorage requirements. We'll work with you to get you the best design for your project, whether it's a value engineering solution or the preliminary design work. We've made it faster and easier for you to obtain your PDH certificates. With our webinar dashboard, you can easily view our library of webinars and download PDH certificates for on-demand webinars completed. Your dashboard will keep a record of on-demand webinars completed along with PDHs earned. Please note that certificates for live webinars are managed separately from the on-demand dashboard, so you will not find your certificate from today's webinar in there if you're joining us live, but you will receive an email from GoToWebinar within the next 2 hours containing a download link for your PDH certificate. In 2 to 3 days, you'll also receive a separate email from Presto Geosystems with more information about accessing the on-demand webinar dashboard and other helpful resources. If you do not receive either of the previously mentioned emails, please check your spam folder or reach out to our team, info@prestogeo.com. Thank you for your time and interest in value engineering solutions for mine infrastructure with the GeoWeb system. You can see more case studies, installation guides, and videos on our webpage, prestogeo.com, as well as on our YouTube channel. Here are my contact details. The Presto Geosystems team and I look forward to helping you with your next mine project. Thank you for joining us today, and I will answer some of our questions following. You can also access this webinar as an on-demand version if you follow the link coming to you shortly. So thank you again for your time. Now on to the questions. First question, can the geocells be reused? They are virgin high-density polyethylene, so they can be recycled. Typically, removing them from a cross-section is not done gently by contractors, so some damage may be incurred. If you're looking for reusable site access, we have a different type of solution called the GeoTerra mats that may be a more cost-effective, equally robust system for you. Please reach out to our team and get a comparison of those two systems. So technically you could reuse the geocells, but practically it's difficult to make that happen in a cost-effective way. Next question is asking for a replay of this presentation. Yes, that will be included as a link in the follow-up email in a few days. Your PDH certificate will come automatically. Next question, can cohesive materials be used for backfill or are select fill materials required? The answer is it depends. Typically, you want to consider something drainable if hydraulics are of concern and pore pressure. Expansive clays, for example, would not make a good infill material, but there are certain considerations that could be made, especially with your on-site material. When in doubt, talk with our engineers and let us see what you're considering. We're happy to look at it with you. Again, that's a free project evaluation service that we offer. Next question, can these geocells be used to support foundation columns and walls for a multi-stage building in a very low soil-bearing capacity area and waterlogged areas? Typically, we do not incorporate GeoWeb in buildings, especially buildings that will have people, mostly for a liability standpoint from our parent company. We have done certain modeling with piling reductions, for example, and things of that nature. Again, contact our in-house design team. Go to prestogeo.com for that free project evaluation, and we're happy to take a look. Next question, does filling the cells with native soil make the retaining walls and road prone to heave action? Also, what is the maximum size of fill for the cells? Again, typically it depends is the answer. And I know that's not very satisfying as an answer, but it depends on the type of soil you're putting in. If you're looking for retaining walls in particular, we'll typically recommend something drainable for the fill. And you have to be careful that drainage is included in the wall design. We're happy to work with you to plan that out and make sure it's all included as a consideration. As for maximum size for the cells, typical recommendations are maximum of 1/4 the cell depth. So again, we can work with you to determine what's best for your particular project needs. Next question, how about asphalt fill? Is it acceptable? I'm guessing you mean recycled asphalt. That has been used for geocell infill in the past. Not sure if you're looking for beneath a fresh asphalt layer or just as a recycled material use, but yes, it has been done. Can these be used for irrigation canals and with what limitations? Yes, absolutely. There's a great case study on our website for an irrigation canal going from the mountains of Colorado out to the agriculture fields on the West Coast. Look for that one in particular. It is considered a best practice by the Bureau of Reclamation for concrete-filled GeoWeb for irrigation canals. So yes, absolutely. And we are happy to look at those potentials with you. Again, as a free project evaluation, activate our in-house engineering team and let them do the heavy lifting there. Is there a maximum height for the geocells in a retaining wall application? How vertical can the stacked GeoWeb wall be? If we're looking at a gravity wall versus a reinforced, like grid reinforced wall, gravity walls can be nearly 90 degrees, like almost vertical. Typically, really tall walls require some kind of reinforcement. And grid reinforcement, for example, those tiebacks are typically 70% of the wall height. So you're not necessarily limited in wall height, but you are limited in tieback length by most of the site layout. That can be mitigated with terracing to some degree. And again, we've done some really tall, like 30+ meter tall walls, and are happy to take a look at your particular project needs. There are a couple questions that are project specific, and again, looking at those specific kind of questions, please reach out to our in-house engineering team at prestogeo.com or info@prestogeo.com. My contact details are still on the screen. You could email me and I'll happily pass those specifics along and help initiate that free project evaluation. How do we take care of high groundwater and seepages? The geocell design allows water to flow freely through the system, both vertically and laterally, and is often used in low water crossings, for example, or areas with environmental sensitivity for minimal site disturbance needs, especially with minimal excavation needs. In our retaining walls, for example, we'll build in drain systems and ensure that pore pressure is taken care of. So that's typically among the considerations our design team makes. Please reach out to us at prestogeo.com and activate our in-house engineering team for that free project evaluation. Another question was velocity limits for channel flow. Again, with our Colorado State University testing, our GeoWeb system exceeded the flow limits of their test flumes for the concrete version over 11 meters per second without any problem. For vegetated flows, that was about 9 meters per second. And for aggregate flows, we were able to reduce that rock size by 2 to 10 times, depending on the inclination of the channel, primarily. So if there's something you're looking at for a high flow option, GeoWeb, especially for really high flow, GeoWeb filled with concrete is a great solution. Next question, is the material of the GeoCell dictated by the type of soil or otherwise? The GeoWeb is always made from virgin HDPE. If you mean the infill, that we will often go with the client's wishes when possible and run the calcs to see if it's feasible based on site parameters. With that, we are already over time and there are still a few questions I didn't get to. We will follow up in the emails coming. Otherwise, if something occurs to you over the next couple of days, please reach out to me. My email is on the screen, or to any of our team at info@prestogeo.com. And we're glad to take a look at your project needs and help you find the best value engineering solution. Thank you so much for your time today. Take care. Be well. Bye-bye.